Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
On today's episode, barriers to future tech adoption with CTO from CACI, Glenn Kurowski.
So Glenn, tell me first a little bit about yourself, what your role is at CACI.
Yeah, so Glenn Kurowski, I am the Chief Technology Officer at CACI, which is a $6 billion Fortune 500 sized company focused on national security. About me, other than the fact that I think the polite word is to say I'm experienced as opposed to older, but I've been in industry 35 years, have been dedicated to U.S. government, military, intelligence, and Fed Civ. I'm an engineer, first and foremost, so I approach everything as an engineering problem. I think like an engineer, act like an engineer, process questions like an engineer. Happily married all those years and 3 kids, and really, frankly, loving what I do.
I'm with you there, Glenn. I love what I do. It's a wonderful industry that we're in. We get to help people and we get to play with really cool stuff, which is always fun. So let's talk a little bit about, there's a lot of really cool technology that is out there today. A lot of really cool, from AI to neuromorphic computing. I mean, there's security, there's a whole bunch of things going on out there. What do you see are the biggest barriers to adopting these technologies in the public sector space?
Yeah, I think you have to look at it through a couple different lenses. I always look first at complexity. We as a technical community, as an engineering community, as innovators across all the industry, we're incredibly innovative, but we're not always good at making things easy to consume, easy to use, easy to administer. So I think complexity remains a barrier. Now we're getting better. There's no doubt that in the last 5 years, the complexity of using AI has significantly decreased in terms of the ability to get more people, leveraging the tools with the software development kits and whatnot. But still, I think complexity is a challenge. Another lens to look at it through is you have to have the talent to architect, design, and deploy and maintain. And I think talent is technical talent remains a challenge in our industry. That's in the ability to get new talent attracted to our industry, especially new talent attracted to our industry that are going to get clearances. But the other side of the talent equation is we still have a large population of talent which is resistant to adopting new technology, resistant to change. And so we have that change management challenge that we have to go through. And many times, if not approached right, that existing talent becomes antibodies to the adoption of new technology.
So they glob onto that new technology and kill it, basically.
They do. Or they come up with, as we say, they have 1,000 reasons why not, instead of coming to a meeting and say, how do we get to yes? And I think that's, an important distinction. The other lens, of course, is, we're always very aware in everything that we do, especially in our industry, right, around cybersecurity. And so that I don't like to describe it as a barrier because it implies it's something we could remove. We can't. We shouldn't remove cybersecurity and assessments and doing things properly. But I do think we can be more proactive at moving the decisions further to the left and involving security earlier, so that we can have accelerated authorizations to operate and accelerated adoptions. But those are kind of the things that come to my mind when people ask me about roadblocks.
It's interesting that you said, because the first 3 are all kind of tied together, right? I mean, ease of use, complexity, skill set, and then, you've got your change agents and I call them change assassins.
Yeah,
but
that's a good word for it.
I like your antibodies. That's even better because they just glom onto it and slow it all down. But there's been some technologies that have been adopted extremely fast. I'm thinking of the smartphone, for example. It was around for a really long time. Mostly business users were using smartphones. And then all of a sudden, Apple just went boom, and the history is told. I mean, Apple's a multi-trillion-dollar company now, right? So what was the main differentiator there? What made it so that that technology could be adopted so quickly and really changed everything?
Yeah, I wish I could have been or had the privilege to have been sort of in Steve Jobs's mind to understand how he thought, because all of us have to respect his success.
Oh yeah.
But I think part of it is can you not help but pick this thing up and just smile? It delights you. It is so easy to use. It is, no matter what we do, it's easy to use. It's got a little more complex now because it's got so much more functionality. But if we just go all the way back to when we really started, jumping onto the iPhone and Android bandwagons, amazingly simple to use. And I think that's the essence of it. I think the commitment by that company to hand people something that they could instantly get great utilization out of, to hand something to a development community that the development community could instantly create and innovate on. The software development toolkits and processes and whatnot were very quite simple, right? We nowadays, this age, we have kids in the 6th grade all the way up developing on the toolkits for Android and iPhone. I think that was the secret of it. And so that kind of gets back to, as I said, they're not overly complex in terms of their use. Their usability is phenomenal. You don't need a ton of talent to use it. It ushers in software development very easily. So I think we try to mimic a lot of those things when we approach our market, when we approach our customers, especially, around the analytics. There's tremendous amount of data out there, but we're not getting a lot of use out of the data. And so we try to mimic this concept of usability, ease of use by sort of designing by the analyst for the analyst, taking all that input from the user and reflecting that, just as Steve Jobs, I think, really reflected the common user, the household user
he actually moved it out of the normal target, right? And he made it so maybe we need to do the same thing with analytics. I mean, the normal target, we always think, oh, I need a data scientist.
Yeah.
Maybe we need a business user, or maybe I asked this question of some of our big data scientists. I said, what will AI do for me? Well, I can look at the data several different ways. I go, so what?
Right.
Tell me, as a normal person, not an Intel employee, but hey, I got a household to run, or my kids' school, or things like that. How is AI going to help me? And there's a quandary. We don't know. So yeah, I hear you there, but we got to figure this one out.
I think when we talk AI and we talk analytics, I think, well, first off, I don't think we can talk about it without being absolutely committed to liberating data. Okay, we have so much data that's actually locked in proprietary designs that it's a bad business model. It's a bad execution model, and we really have to be zealously committed to liberating the data and getting it out there and not existing for the purposes of I want your data, I want to hold your data, and now I'm locked in. I actually would like to be able to help you get your data liberated and earn your trust as a provider, as a solution provider every day by adding value and innovating every day. I think you'll renew my contract as opposed to having to renew it because I happen to have controlled your data. But to your point, I think of artificial intelligence, I think of analytics as what I need to provide to you as a digital assistant. Okay. First off, I don't want this murky, magical, robotic thing in the background that you're kind of nervous about trusting.
Oh yeah.
But the words digital assistant don't scare you.
No, they don't.
They make you feel like I'm thinking a step ahead of you and presenting you kind of the data that you're about to ask for. And that's really how we think about the intelligence analytics, the intelligence analysts sitting there to get an outcome. We kind of know what tranches they're working in, right? They may be looking at video and trying to find objects, or they may be, tracking down criminal activity on the dark web. So they're looking at they're following the money through cryptocurrencies and whatnot. There's a sort of a normal kind of progression of the types of analytics and forensics that you would do. A digital assistant simply tries to be a little bit ahead of that. And you can do that with machine learning and deep learning and natural language processing, all those terminologies we get underneath the umbrella of artificial intelligence, but without the scary concept of a robot making decisions. Rather, I'm serving up the information that just makes your life easier and lets you do the processing still, but it's assisting you, and that's not a scary thing.
Yeah, I'm glad you brought up the scary thing, because that goes into those antibodies that glob onto technologies and kill them, because it comes out of a position of fear. Fear I'm going to lose my job, fear my data is going places that it shouldn't, fear of exposure, lots of fear. I find it fascinating, if we go back to the smartphone analogy, if Steve Jobs came out and said at the beginning, I'm going to put a camera and a mic in everyone's home, it would have killed it right then and there.
The antibodies would have been out.
Yeah, he did it though, because he didn't couch it that way. So same thing. I love how you said, hey, let's call them digital assistants instead of AI bots or AI, So I think it has a lot to do with positioning and also ease of use and getting buy-in from those change assassins, right, that are out there to kill technology.
And providing instant value to the folks who are going to demand more of it, right?
Yeah.
Once you provide value to the analyst, once you provide value to the person who's going to get an outcome out of that data, actionable intelligence out of all that data, they get a big vote, right? They scream very loudly because they have a mission to do. And when you give them something they like, they'll certainly pound the table. I want more of this, and that's honestly, that's what we want our customers to depend on us for, right? If they depend on me for that, they've trusted me, they've given me the responsibility of being a step ahead of them in terms of what they need. And again, I think if you do that right, your contracts are renewed, your recompetes are won, and you don't have to have locked them into some proprietary model or some proprietary story.
Yeah, I really like that proprietary, because that has been used as a tool, right, to thwart competition. Was, hey, my device only talks on a proprietary protocol, and you have to always use me. I totally agree with you. People want more open systems. They want ways of, I love the liberation of data. All right, let's talk about technology. Let's shift it a little bit about technology that you feel you must have today. These are things that, if you don't have these, you're already behind.
Yeah. And like a lot of your questions, I think you have to look at it in a couple different lenses, because there's, in our world of technology, it's pretty broad. I'm always struck by the fact that in last year, we celebrated the 15-year anniversary of the first EC2 instance in Amazon
That's
Web
amazing.
Services. And 15 years. I mean, think of the number of technologies that have come and gone in 15 years. I mean, that's a lifetime, right? That's a lifetime in our technology world. And yet, with using EC2 as the metaphor for cloud for just a moment, right? 15 years in, and we are still absolutely in the early innings. And so the not so sexy, glitzy, new whiz bang thing answer to your question that you got to have right now is cloud. And I think we need a lot more of it. It is, it takes a lot of the human error out of common administration. It lowers the attack surface from a cybersecurity perspective. It's obviously a pay-as-you-go consumption model, which can have, if you develop the software to that model, is a great economical reason to go to that. So I think again that not as fancy, not as mind-blowing answer is cloud. The second one is around software development, because I again, you and I have been a long time. We programmed when we worried about having 16K of RAM.
Yeah, we did.
To a student today, they don't even care about how much memory they have. They don't. There's a limit. 16K of RAM,
is so
8K
true.
of RAM. Are you out of your mind? But today's development environment, the tool sets that our programmers can have today for DevSecOps are unbelievable in terms of sort of removing me from all the parts of the jobs over the previous decades that I didn't like to do, right, as a software programmer. And now we can get a lot more actual programming, a lot more, true development, and spend more time in an agile process with the end user to get these things. So I think DevSecOps, again, Still in the early innings, really explosive growth. We're finally getting our first DevSecOps true platforms on the market. We've had a lot of open source pieces that we've put together in a tool stack, but now with something like GitLab, we have a platform that we can do so much more on. So I think that's another one. I guess to get more pointed, and we learned this, we saw this happen because of COVID, because of the amount of remote work, the demands on the desire to get from unclassified to classified from an unclassified world. In other words, I'm at home, but I've got some limitation of perhaps why I can't be where I'm going to be on a secret enclave. So using commercial solutions for classified, or CSFC, been around for a number of years. I bet you, I think I can say it's been around at least a decade. But right now, I think we've gotten to the point where that technology has matured to the point where we've taken the complexity out of its deployment, the complexity out of its administration, the complexity out of the security, accreditation, certification type processes, where CSFC can be brought to the edge quite easily and allow someone to work in an unclassified domain and access secret domain, just as an example. So one up to the other, and have a lot of confidence that we won't have any leakage. And so I think that's now turnkey solution. That's now sort of software as a service or a lease capability. That's why we bought ID Tech at the end of last year. We felt that they were in combination with Dell. In fact, your product's embedded in there. A lot of Intel gear embedded in there. That was just, so I think that's a must-have right now. And I don't say that because my opinion, my customers are telling me that.
Yeah, it's interesting because you brought up some really hot topics: automation through DevSecOps, cloud technology, and what I would call the hybrid worker now, where I can get access to the data I need, whether it's classified or unclassified, anywhere, and still be secure. I'm seeing those same things, not just in the public sector, I'm seeing in the private sector as well, where
and I was gonna say, it ties back to, believe it or not, it ties back to talent, right? Because talent leaves our industry when it becomes too annoyed at the constraints that our industry may place upon it, right? Oh, the only way you're going to work is you have to go into the skiff. Or you've got to do software in a certain, used to be you had to do it, here's the waterfall methodologies, and now at least we've fully embraced agile, we've fully embraced the faster methodologies, fully embraced DevSecOps. So I think I'm very happy our industry is leaning forward in that, because I think it really makes it more appealing to the talent that we're recruiting every day and trying to retain every day.
Right. Otherwise, you end up with a bunch of cabbage pickers. Do you know that story of the cabbage picker?
I don't.
Oh, this is all. It's one of the co-founders of Microsoft. He left. He was burned out of technology, and he went and picked cabbages down in Watsonville, about 30 miles south of the Silicon Valley. And so he missed out on that whole thing because of all the restrictions and things that he was just burned out from technology. Oops. I mean, that's a major oops. But I'm seeing more people. I agree with you. I'm seeing more people that are leaving the industry than joining the industry. And we really need top technical talent. You brought that up at the beginning.
And it's not because we don't have challenging problems. I mean, the challenges that we have as in dealing with national security are just, they're eye-watering in terms of how excited you can get around them. So I think some people have the misnomer that the government moves very slowly. It's got a lot of red tape. Well, there are aspects of that are important in terms of maintaining, a certain sanctity, a certain confidence in solutions. But actually, we're on the, we're right there on the innovation edge on so many different technologies, whether it be photonics for light-based communication, or what we're doing in software development with Agile and DevSecOps. I mean,
I've seen that myself. I've been kind of surprised when I started working in this part of the industry that, they do move fast in pockets. And then
it's appealing stuff, right?
Yeah, it is. Those are fun projects to work on. So let's talk about fun projects to work on. Let's talk about the future. Where do you see technology in the future? I have some crazy ideas. I know you do because we already done this podcast once, but so tell me, Glenn, where do you see technology 5 years, 10 years, even 20 years out?
Yeah, crystal balls, right? They don't
Yeah.
work. If I had one, I'd be investing and probably not be on the podcast. I'd be on a beach. But I think again, I use this. I say this to a lot of questions people ask me, and I don't mean to be repetitive, but you got to look through it different lenses. So let's start with the domain lens, right? In our industry, we've tended to talk about air and sea and land domains, cyber domains. There is a space domain. There has been for decades, but I think we're at the point now where the space domain is exploding. We have the ability with size, weight, and power to put a lot more on orbit inexpensively. We have the ability to communicate with light, with photonics over thousands of kilometers. In that low size, weight, and power, in that low cost payload, and do gigabits per second. And so that type of connectivity, that ability to distribute data, to use data on those payloads is fascinating. So I think one of those things that's coming very, very quickly and will fundamentally be different, than it was now in 5 years is the use of the space domain for certain. I think the other area, is what's happening with spectrum, the electromagnetic spectrum. Clearly 5G is phenomenally interesting, and interesting in how it's going to use the spectrum and make use. But I think if we think bigger on the overall use of the spectrum and the overall use of our operation in the spectrum and our adversaries, and basically peer adversaries' operation in the spectrum, makes that almost equivalent to a domain. The electromagnetic spectrum, the domain of the electromagnetic spectrum. We're going to, the next conflicts, still are going to have heavy emphasis, right, on the bits and bytes and who can communicate, who can do SIGINT, comment, and whatnot. So I think the ability to have spectrum agility, right, the ability to know dynamically what's going on around me in the spectrum, how can I move quickly in the spectrum, can I detect, can I deceive someone, can I deny someone, can I protect my own communications, my own ISR within that spectrum, can I build resilient comms which are dynamically using the spectrum, sensing what's around and moving around. I mean, that's the fundamental thing. If we want the joint all-domain command and control to work, the JADC2 vision to work, it depends on the ability to have connectivity, and that connectivity has to be resilient. And the way to be resilient is to use the spectrum and move around in the spectrum very, very differently than we have in the past. So that'd be a second one. Third one, well, I think we're just touching the surface on what we can do with Kubernetes and with infrastructure as code. And I just think, I love watching today's digital talent pick up that technology and show me something almost every week that I could not predict.
Wow.
Could be done, and how that can remove labor, can ease things, automate and things like that. So I think that's coming. Further out in that crystal ball, I mean, we can't really have a conversation about the future without at least mentioning the Q word, quantum.
Quantum, yeah.
I think you're right. We did talk on the podcast last time. I think I told you my story. I spent 30 years at an aerospace company. Terrific career, terrific experience, nothing negative about it at all. And that aerospace company announced in 2011 that they were partnering up with D-Wave on quantum computing. And I said to myself, man, it feels really early. And I put a Post-it note inside of my engineering notebook. In fact, I bet you I still have it. I move it from notebook to notebook to notebook, and it's still in this one that I got here, which says 80 qubits. I will pay attention.
We're there, Glenn. You better
stable.
Wake up.
Right.
Yeah.
But here's the asterisk that I wrote down, about 2 years ago. You got to give it to me with a software development toolkit.
Well, I think you hit it on the nose. And this goes back to your first thing, the barriers to adoption of technology. Quantum is still very difficult to even wrap your head around.
Yeah.
And then the programming models are being built right now, which to me are completely different than your typical programming models that I grew up with. So it's going to change. And
I think it's in parallel to sort of artificial intelligence. I mean, 5, 6, 7 years ago, when I was talking to somebody about deep learning, I was talking to somebody who was talking to me about developing the algorithms. and talking about the neural network and how many layers, and they tried 7, 8, 10 layers, whatever layers. People who are doing deep learning today rarely talk to me about
No,
that.
they don't talk. Yeah, you're
Right.
right. So it is
Because
moving up.
we have toolkits that make that much more automated. And I think that's where we have to get with quantum is I can't afford as a development community to have to go train somebody for 2 years to be a quantum computing, a programmer who can use quantum computing. It doesn't scale. It doesn't scale. So we have to get those software development toolkits that allows us to do scale. And that's what the community did for artificial intelligence, right? They we can't say dumb down. That's not what they did, but they
No, they
abstracted the
abstracted it.
complexity.
Yeah.
Exactly. They abstracted the complexity, and they gave us toolkits that allowed, the quick adoption, and then folks just got better and better. And I think that's where we have to get. I think we're still a little bit away from that. I've talked to some of the providers, and they're starting to make that simpler, but I think that's important. The last one on the future from my perspective is probably just the continued evolution of what's at the edge computing, the creativity we can do at the edge, with size, weight, and power. I mean, it is, we lose track of just how much processing power is in this, because it's not just processing power, it's number of processors, right? The number of inference processors that are processing, my voice commands and all that kind of stuff, the number of compute processors. It's just phenomenal. And this is awful light. It's awful small. Its battery is getting better and better every year.
And it communicates too, right?
Unbelievably, yeah.
Yeah.
It's a software-defined radio, right? Everything is software-defined. But I think edge computing, will continue to transform what we can do at the edge, how we can secure and trust what's at the edge, how we can resiliently communicate with that edge, where perhaps it's not a dedicated connection, but rather a mesh network, and parts of the messages go out and they recombine at the other end in sort of those environments that we provide solutions in, right? In the tactical environments and in the denied and disrupted environments. So I think that's the other one. So those, I guess,
those are some pretty
5.
big. I mean, those are some pretty big ones.
Now you said you got some crazy ideas.
I got tons of crazy ideas.
Yeah.
Especially as you start seeing more heterogeneous platforms where there's multiple processors. I see the traditional von Neumann computer model going away, where now we can really we can have persistence of data without disk drives. We can have data that lives and moves and migrates around with functions that work with it. And I think I told you last time I was trained in object-oriented systems analysis. And I had this crazy dream when I was in college that I just create objects in the computer realm that have their functions at work, and those objects have a lifetime and they move around and they grow and learn over time. And then I got into reality where I had to really program real stuff. And it didn't work because of the limitations of network speed and just the von Neumann model in general. All these layers of data marshaling and caching and all this stuff. I think that stuff can go away. We have persistent memory now that's pretty darn fast enough, low power. We've got specialized processors that can do amazing things with data and then push the data and the algorithms back out somewhere else to have it run somewhere else and do something. So I think, and those programming models are difficult, but I think we're headed in that direction. I would love to see that. But
I think it's coming quicker than you or I would normally predict, because we're still biased by our experiences. So and it's a different world. Your company with your Intel Capital arm invests in some pretty neat companies. I've had the chance to work with one. So for those that don't know what the von Neumann architecture is, just think of if you took any kind of computer science or computer design, you always had, here's the processor, and then there's a bunch of lines that came out, here's your memory, and you always had this latency between that, and then
then your storage somewhere else,
and then of course you had the caching to make it faster, blah blah blah. But if you can get that stuff to basically be coexistent, imagine what you can do with the speed of inference
Yeah.
at the edge, which is what we need, right? To have driverless vehicles, to have, fully autonomy. We have a lot of inference happening, a lot of artificial intelligence inference engines that are happening, and we need that done at a very, very high speed because we need, very, very low latency comm and very low latency intercommunication so things don't bump into each other and whatnot. And that technology is happening. And what I like about it is the fact that they are considering abstraction layers from the start. So that the programming models that I could take a neural network model that I've already developed, run it through a software development toolkit to place it onto that hardware substrate, onto that non-Neumann architecture. And then, so I didn't have to reprogram for it.
Yeah.
Right. Yeah. And I think that's gonna accelerate the adoption. So I believe in that one. I believe in that one crazy idea that you just put forward. I think that's coming. I think it's gonna be transformational.
Yeah. And I'm hoping for some of the other ones. I mean, I can't wait to have 1,000 core box with a petabyte of memory in it. That's that's persistent, that runs at the speed of RAM. Because if you give me that, I can change the world.
Now, remember, we started this off saying that we programmed with 8K of RAM.
Yeah, that's right. Well, hey, I'm up to a petabyte of RAM now. So
it is really cool to have experienced all that and seen that in our lives, and to be able to tell the stories about it. We probably sound like grandfathers, saying back in the day,
back
when I
in
had
the
a
day,
needle
yeah.
and a disc, and it played music. But
well, hey, Glenn, it's always a pleasure to talk to you. I always have a lot of fun, and thank you for coming on the show. I appreciate it.
Yeah, thank you so much. I really enjoy the interaction.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.